In this video, I want to show how we can access array elements, and I want to use a school building as an analogy to an array. So arrays are like school buildings. Every school has its own name. For example, the name of this school is Nigerian Turkish International College. The same way, every array has its own name. For example, this is a definition of an array of int type, and NTIC is the name of this array. A school may or may not have many classrooms. The same way, you can create an array with elements as many as you want. For example, this array has size declarator 10. You can store 10 different elements, 10 different values. So next, in schools, every room has its own label on its door. For example, primary 4A for this room, primary 4B is for this room, and so on and so forth. For example, let's say you came to pick up your kid who is in primary 4A. Then you go to this classroom. You don't go to, for example, primary 5A. The same with arrays. We already know that the contents are stored together in consecutive memory blocks. An array has an index which pinpoints each and every one of these elements. And for these indices, we call subscripts. And subscript numbering in C++ always starts from 0. And since it starts from 0, the subscript of the last element is going to be always one less than the size declarator, the total number of elements. Next, let's say I am a principal of the school and I decide to put 20 students into this classroom. And after a while, I may change my mind, and this time I take those 20 students and instead put 10 students. The same way, I can access every element, and I can do it by using the subscripts. So let's say I want to store number 20, to the first element of an array. So I have to write a statement, and the statement begins by the name of an array. What is the name of an array? It is NTIC, and in brackets I'm going to write the subscript of the first element, which is 0. So NTIC sub 0 equals 20. So by using this statement, I am storing number 20 to the first element of an array. Let's say I want to store number 10 to the sixth element of an array. So the sixth element of an array is this. And let's write NTIC brackets, and in the brackets, I'm going to write the subscript of this element. And the subscript of this element is 5. So NTIC sub 5 equals 10. And now you may get confused which one is which. Which one is size declarator and which one is a subscript. And let me write one of the statements in here so that you can compare them easily. So NTIC sub 0 equals 20. So the number inside the brackets of an array definition is always size declarator. So this is a definition of an array, and this 10 is a size declarator. And the number inside the brackets of an assignment statement is subscript. So this is a subscript. So let me show you this in the code. So now let me write a definition of an array int NTIC, and in brackets I'm going to type 10. So I can store 10 different values. I can store 10 different elements here. Now I want to store number 20 to the first element of an array. So I'm going to type NTIC. But what is the subscript of the first element? It is always 0. So NTIC sub 0 equals 20. And now let's print it out. NTIC sub 0. And let me run the program. IStream. As you can see, it shows 20. And what is 20? The content of NTIC sub 0. So now I want to store number 10 to the 6th element of an array. So NTIC, then sub 5. The 6th element of an array is going to be, the subscript of the 6th element is going to be 5. And I want to store number 10. And I want to see the content of NTIC sub 5. So std cout and NTIC sub 5. Std end line. And let me do here the same thing, std end line. So let's run the program. And as you can see, here we have 10. And what is 10? 10 is the content of NTIC sub 5. So when I assign 20 to the NTIC sub 0 and 10 to NTIC sub 5, what happens to the other elements of an array? So there are two options. It depends on the array. If the array is local, meaning it's defined in a function, then the contents of these elements are unknown. They can be anything. The content will be nonsense values, which we call garbage. Let me show this. I'm going to delete these statements, and I'm going to use the for loop int x equals 0, and if x is less than 10, x plus plus. And in here, I want to see the content of every element of this array, NTIC, and in the brackets, I'm going to type x, std, end line. So let me run the program. As you can see, we can have numbers that we didn't assign. For example, NTIC x, the first value of x is 0. NTIC sub 0 is going to be 20, and here it is. Then the loop goes and NTIC sub 1, and we didn't assign any value to NTIC sub 1, so it's 0. And then NTIC sub 2, we didn't assign either, so but there is a number which we call nonsense value, or actually garbage value. So this, if an array is local, then the elements that you didn't assign any value, they can be any value. There can be nonsense values, just like you see here right now. But what happens if an array is global? So let me cut it, and I'm going to make it global, meaning I'm going out from all the functions and I'm going to paste it here. Okay, then what happens? The contents of the elements is going to be initialized by 0. So if an array is global, then the contents of uninitialized values will be 0. Now I'm going to run this program. As you can see, the first element is 20 and the 6th element is 10, but all the elements other than the first and the 6th are 0. It's because array is global. So let's practice what we have learned, and for this, let's make a program that asks the user for the number of hours worked by 5 employees, and these values will be stored in an array, and then we are going to print out these values on the console. So now I'm going to write a definition of an array. So int hours worked, and in the square brackets In the square brackets, we are going to write the size declarator, and instead of writing 5 or for example 6 or just a number, I'm going to use named constant int, and let's say employee number, and let's make it 5. So I can use a named constant as a size declarator. As you remember, the size declarator must be a constant or a literal, but when it comes to subscript numbers, they can be stored in a variable. So what does it mean? It means that we can use subscript in the loops. So now I'm going to use a for loop to ask from the user the number of hours worked by employees. Int x equals 0, and x if is less than 5, x plus plus. And now we are going to ask the user to enter the number of hours the employee worked. So std cout, enter the number of hours worked by employee X. And let's give this sign std cin, and now we are going to input data into the array, which must be done one element at a time. So I'm going to type hours worked, and instead of writing the number in the brackets, I'm going to type x. So you cannot do this. You cannot just write the name of an array. Why? Because we cannot do the way we did with variables. It is an array, so, and in the square brackets, I'm going to type x. So this loop is going to step through the array, reading data into its every element. So now let me run this program and see what happens. As we can see here, enter the number of hours worked by employee 0. Why? Because here we have x, and x starts from 0. Do we have employee 0? No, we don't. So we are going to increase x by 1, just here. Okay. Let me run the program. As we can see, enter the number of hours worked by employee 1. Now it's correct. Can we do this in the for loop? For example, we can initialize x by not 0 but by 1. But what happens then? When I run this program, it's working fine. Enter the number of hours worked by employee 1. It's okay. But then, let's say you input 12. Then hours worked and x is 1. So it's going to skip the first element, which is hours worked sub 0. So that's why we are going to initialize x by 0, but here we are going to increment it, and it's going to fix our problem. For now, it's going to work fine. Now I'm going to take a screenshot of this code. And here we are. And now I'm going to show you how we can read data into an array by using the for loops. So here, x is initialized by 0. The value of x is 0. Then it will print out, enter the number of hours worked by employee. Let's imagine that this is our console. Enter the number of hours of employee, x plus 1. x is 0, 0 plus 1 is 1. So, and then it's waiting for you to enter the value for the first element of an array. Let's say you enter 12. So this 12 is assigned to the hours worked sub x. And what is hours? Hours worked sub x. What is x? It's 0. So hours worked sub 0 is going to be 12. Next, x is increased by 1. So new value of x is 1. Then it's going to compare x, whether x is less than 5. Yes, it is. Then it's going to print out, enter the number of hours worked by employee. Enter the number of hours worked by employee, x plus 1. What is x? It is, the new value of x is 1. 1 plus 1 is 2. So 2 will be printed out. And now it's waiting for you to enter a value for hours worked sub 1. So let's say you entered 45. So hours worked sub x. What is the value of x? It's 1. So hours worked sub 1 is 45. So by using the for loop, we are stepping through the elements of an array and assigning values to the elements of an array. Now, by using the for loop, I am going to print out the contents of the elements of an array. Let's go to the code. For int x equals 0, if x is less than 5, x plus plus. And now I want to print out stdc out. Now I'm going to print out the contents of hours worked array. So hours worked, and again in the brackets I'm going to type x. And let me give a little bit of space so that we can understand all these numbers. And let me give a message stdc out. Hours worked by employees and let me give a new line before the hours worked by employees message. Let me run the program. So enter the number of hours worked by employee 1. Let's say 12, 45, 78, 23, and 56. As you can see, hours worked by employee is 12, 45, 78, 23, and 56.